I'm going to pass it over to James. So thank you for joining us.
Thank you. Can you hear me all right?
You sound good to me.
Perfect. And the slides are there, hopefully. So my name's James Daniell. I'm currently at Karlsruhe Institute of Technology, as well as at the World Bank in a group called Disaster Risk and Analytic Solutions team. Yeah, I've sort of been dealing with disasters most of my life. So my dad was a flood engineer, mum was an historian, and used to get dragged around Australia to all the different flood sites in real time. And so sort of that then piqued my interest and continued on analysing disasters in real time and collecting disaster data around the world. And yeah, this is one application of sort of all of this disaster collection, I suppose, over the last years, is that we developed a thing called the Global Rapid Post-Disaster Damage Estimation Approach, which is used in sort of the post-disaster phase, also in near real time for cyclones, but post-disaster phase to try and work out or estimate the economic cost of the disaster. Now, Cyclone Idai was one of the big events of 2019, somewhere between 1,200 and 3,000 deaths, depending on how you, which estimates you're using. It affected 3 countries in Africa: Malawi, Mozambique, and Zimbabwe. And straight after the disaster, the governments grappled with the questions, I suppose, which all governments grapple with after a disaster. How do we assess the damages? You know, we haven't had a disaster of this size for a while. Where's all the data? Where are the damages distributed? Because obviously there's impacts across all different places in the countries, as well as, you know, what is the socioeconomic impact as well associated with this? How am I going to, you know, pay the bills after this and so forth? Now, after disasters all around the world, I suppose a good analogy is probably the US elections. There are a lot of assessments which come out often very, very quickly, which may not have a huge amount of basis behind them. They might have historical data, or they might just be an estimate. You know, I've won the election versus waiting to count all of the details over time, right up until the final vote, which may be, you know, 10 months in the future. And then you could give the assessment. In reality, so for disasters, we need something in between. Those first estimates are, of course, sometimes useful, but there's a sort of a sweet spot where an estimate is good enough to be able to then provide enough detail that then the governments can really use it and go ahead with their sort of economic planning. So there's lots of different post-disaster tools around the world. Obviously, GDAX comes out in real time with a lot of disaster data. These types of rapid loss estimation approaches based on a lot of historical data create an estimate for disasters. Then you have sort of another swath which are a bit slower, some coming from, you know, civil protection agencies, from commercial companies. They're often black boxes, and then they come out with an estimate. Then we start getting, you know, in the order of, you know, 6 hours, 12 hours. You sometimes get satellite studies, as well as sort of damage proxy assessments and things like this, Copernicus and so forth coming out. Then a lot of data obviously comes through humanitarian agencies, ones on the ground, and sort of hybrid reports like ReliefWeb. Then your big insurers, reinsurers will have a look at their portfolios and they'll try to scale up an assessment based on that. You might have government institutions tweeting, using Facebook and doing these types of things to give assessments. Then you'll have research in universities, and this is where you start getting into a few more detailed assessments and a few more sort of detailed values coming out across lots of different sectors. Then you have the PDNA and DALA, and PDNA and DALA is the post-disaster needs assessments. And they're done generally between the UN, the World Bank, and the EC, European Commission. And this provides sort of the real assessment for sort of recovery needs and planning. And this often takes somewhere between 2 and 10 months. So this is why this approach was sort of wanted, to sort of fill the gap of being quick enough that we can use it for a quicker payout, which means that you can obviously help things, as well as being, in good enough detail. So over the last 5 years, we've applied this to 20 major disasters globally, but we've covered every other disaster through rapid loss means. So 24/7 around the world for the last 12 years, we've been covering every disaster. But this grade approach has only been applied yet so far to about 20 disasters. We're doing Turkey at the moment as well. But yeah, it's no longer a 2 months to 10 months sort of detailed method. It uses a 2-week methodology to try and get at this assessment. So the skill is really in its analysis, and it uses all the aspects, I suppose, which Sarah had in her topic beforehand, so in her talk. So you have the hazard aspect, so you have the event scientific data, creating, the footprint of the disaster, the historical damage data, and this obviously is used a lot through my CatDat database, but also through whatever databases that the countries have. Socioeconomic data, having all of those proxies and all of the building assessment sort of data, census data, everything already geocoded in advance of the disaster is extremely important. Remote sense data, social media data we use in that 2-week period, vulnerability functions, and obviously the damage on the ground itself. So this is sort of the unique thing about this, is that it sort of mixes modeling with then all of the damage assessment which is going on in the first 2-week period to sort of update the modeling. So you might start off with your wind field, and then it will be modified by all the local aspects that you're getting off the ground. And so in the places where you know the damage, then you'll be using that. But in other places, then you'll use proxies based on, relationships of vulnerability and so forth. So we do this globally. For weather-related disasters, mostly cyclones, riverine floods, and flash floods. Temporal scale is really post-disaster in that 2-week period. What the magnitude of the events for grade? For grade, it's generally the larger events. And in terms of the complex overlap events, yes, it's sort of flexible, I suppose, in terms of using modeled versus using the survey data and using the unknowns, because again, cyclones are complex. They have a wind aspect, they have rain intrusion to make the damage, they have flooding, often storm surge associated with it, and you can't usually apply a basic function to get at what the economic loss of a building is, because it's affected by 4 different things. And so often it's quite a difficult thing. We do use remote sense data as well, so we don't not use it, but it's often used just as sort of a checking mechanism, as with a lot of things. So we do use Copernicus, we use area proxy damage maps in the first couple of days, just to sort of check our modeling as well. But often by, within this 2 weeks, you're at least getting ground-based reports from the governments and from subnational government agencies. But it's still a very useful tool, and obviously as it improves, then hopefully we'll be able to use it even more and more as we go on. So just sort of focusing on Cyclone Idai now, and sort of going through sort of how we sort of did it. So it was, as I said, quite a big sort of cyclone. By the time it hit landfall for the second time, there was about 200 km/h winds, about 10 minutes sustained. So, it was a big hit. There was storm surge. There was a lot of damage near Beira on the coast of Mozambique here. And it went inland as well. So you were still getting damaging wind speeds in Zimbabwe as well. Now, before it went in for the second time, it caused quite a lot of flooding damage as a tropical depression and low pressure system through Malawi and Mozambique. And actually you had some locations that actually got hit twice by sort of the rainfall. So you have 2 events where you're trying to, correlate the damage as well from the first event to the second event and so forth. So what's the first thing that we do? So what we do is that we first work out, what are the languages in these countries. So that's the first thing. As soon as you see that there's a disaster occurring, find the local languages. So for Zimbabwe, that's Shona and English. For Mozambique, it's Portuguese. And for Malawi, mostly English with a combination of other languages. And always the best data is coming out in the local language. It will then be translated. It will then be, adapted and put into other forms. But yeah, if there's one thing I can say from the last, 20 years of covering, disasters in real time around the world, is that best data and the best information is always coming from local language first. The disaster assessment process that we use is the same as any other disaster assessment process. We have sort of the pre-disaster context baseline, and that baseline is extremely important. We have this for lots of countries all around the world, obviously within the bank. So this is built from open data portals, from census data, from all different types of baselines. Of course, there'll be information, and there'll be new information always coming out from these open data portals. So during this 2-week period as well, we're always updating the baseline as well. So getting the best data for where the schools are located, what is the value of the schools, and so forth. In terms of disaster effects, we've mainly focused on the capital damages. We've found that obviously you can always do a loss assessment for the losses side of it, but in reality, that really goes beyond the 2-week period, and it is affected by so many other proxies. So we really focus on the capital damages. And we're really trying to get through to, what is the disaster impact in terms of replacement cost, but then what are also the recovery needs. So in terms of building back better, in terms of disaster risk reduction, and sort of the value of the damage and cost and so forth. And then to help, this sort of will inform then the recovery strategy. So in terms of IDAI, what were sort of the modeling challenges? In the first day, you sort of get out all the information. You've got the 3 countries sitting there, and you go, well, okay, there's no pre-existing model. We've got stochastic risk models that we've built for various, companies around the world. And yes, they do cover Mozambique, but they don't cover exactly this event, and they don't cover the amount of rainfall that we were seeing, and also the combination approaches of this storm surge, of this rain intrusion, and other things as well. So we started from sort of blank for this case, because also we had the 2 landfalls and this mixed bag of damages that we were seeing. We also had a lot of delayed and conflicting damage reports, and this often happens as well, and I suppose Sarah touched upon this as well in her conceptual knowledge base, is that there are huge amounts of different conflicting reports, and that's part of this work in the 2-week period, is to sort of take the really good parts of what we can trust in terms of social media, in terms of citizen science reports, as well as from the government, but also to throw out certain things. We can test based on the baseline. We can test, is this assessment of the government of 1,000 schools destroyed realistic? Because actually they only have 400 schools in this province. And so you can sort of start assessing all of the information which is coming out. We use exactly the same process as a normal risk model would. So we use hazard, exposure, and vulnerability. For the hazard, we start off in the first couple of days with flood footprints, with wind fields, but from all different types of wind models. Storm surge, of course, from all different types. But then as we go on through the disaster, these become less and less important, because we are adapting it based on the data which is coming in from the ground in terms of the observed damages. And of course, we need a huge amount of building and capital stock data, as well as historic and engineering damage data as well, to be able to do this. So what are the 2 key things? Well, we benchmark against historical disasters. And again, this is where the team that we have is quite unique in that we've all been collecting our own damage databases through time around the world. And so it's sort of, it's quite nice, because we do have these huge damage databases that we can sort of find disasters in the past, which we can then sort of look at and then see, okay, does this make sense with this disaster? As well as the validating against damage observations. And I think this is sort of the other key aspect of GRADE, is that it really is sort of using the damage estimation from the ground to update a model. And this is, I suppose, sort of the unique part of this. So in the end, what do we deliver? We deliver then the estimates of the capital damages by sector. And it differs depending on the grade and depending on the quality of information and the trust that we have in the model. So if we don't trust the agricultural part of the model, we don't deliver it. We then wait for the pDNA 2 months on or 4 months on to do the on-the-ground full assessment. But if we're comfortable with that, we've got good agricultural census data, that the land use patterns are making sense, that the yield profile in terms of the damage, say, to vanilla beans or whatever, that was actually from the Madagascan ones, but from for whatever agricultural crop sources that are there, if we're comfortable with the damage functions and the damage we're seeing, then we'll give that assessment. So the cyclone impacted 3 countries, Mozambique. So this was the Mozambique assessment. And again, we split it down by provinces as well. It depends again on the disaster. So of course, when we're modeling it, we model it on a much higher resolution than this. But we find that it's important to obviously find the right resolution for the government to understand, you know, where do I need to put my resources? And so often we scale then this high resolution back to a lower resolution where they can actually take it all in. Then we also often use economic metrics to explain it to them. Although it's capital damages, of course, capital formation takes up a part of the gross domestic product, and so gross domestic product is often a good sort of way of explaining it to a government, especially since most governments around the world are only interested in a 3-year shelf life or a 4-year shelf life. So often they're really only worried about GDP rather than capital itself. Cyclone impacts in Zimbabwe. So obviously this comes inland, and again, it's quite interesting because the information flows are often not there within some of these countries. And so often this is the first sort of real assessment that they get before, you know, a few weeks to a month on where some of the disaster data starts coming in as well. So it differs all around the world. And Malawi as well, this was more flooding aspects, and so these were the results. So how does this inform things? Well, it goes into the World Bank regional response, so that rapid damage assessment is done. Then it will be used in terms of the response mechanisms. So in Mozambique, in Malawi, it was used directly. And then it supports also the pDNA. So the post-disaster needs assessment is often still done after this. And in all of those cases, the economic assessment has been within 10% of that final pDNA. So it's working really well, which is good. It sort of is the joining of rapid loss modeling to sort of this damage estimation. And it really only is because open data and data around the world is improving so much. Otherwise, this wouldn't be possible. And so in the end, what we can get is tables like this, where this is the recovery needs, and we know that there's about 2.4 billion, and then we go to the donors, and everybody discusses where is this money going to come from, to what percentage of it is going to be funded globally versus from the governments themselves, and then they can use this for organisation. So yeah, there's further reading associated with this if you're interested, and yeah, obviously there's a lot of aspects in grade. And we're always sort of refining it as well. It's very dynamic, but yeah, hopefully that gives you a little bit of an insight into what we do.
That's great, James. Thanks so much for giving us that very thorough overview. I think there's a lot of information to follow up. It's interesting how this type of information, in some cases we tailor it to specific policy needs or decision makers. In other cases, we're talking about broader public behavior and trying to influence that. And it's really the whole mix, and it comes together in what you presented, I think. We had one question from one of our presenters, from Jeff Lazo, that I'd like to raise. He says, how does grade compare or relate to MDAT data? So I guess the sources of data that go into your product here.
Yeah, so I mean, grade is a sort of a damage estimation as such. So you could think of this as one line in MDAT. MDAT would take this grade value and put it in their economic effects data, data point as such. So I suppose it's a little bit different in that respect. There are a lot of damage there are a lot of sort of damage databases around the world as well. So loss databases. So there's MDAT, there's CatDat, the one that sort of I've been collecting. There's Desinventar, there's the Swiss Re Sigma, Munich Re NatCat service, and all of these obviously have their strong points and their weak points. MDAT was based on OFDA, a 1972 database. There's some of those past disasters maybe should be reassessed and things like this. That's sort of MDAT. So again, it's always best to go back to those original sources again. So as I said, always trust local and go back to original sources. And I think we're getting to a point where around the world there's sort of each country is taking their own sort of assessment, which is good because it means that we're getting now 244 country databases hopefully at the end, and it sounds like we'll have a good integrated one for New Zealand finally as well. So yeah, that will be obviously extremely useful because through those historical events, we can often use this as one of the first proxies by using normalization techniques and things like this as to what the economic value of that event that is now occurring that it could be. And so that past event data is extremely important. So yeah.
So I should qualify the question from Jeff. He had asked that very early in your talk, and I think found an answer, but that was a much better answer, I think, that you just gave. One follow-up question. I'm not going to follow up. Jeff has a second question, but he can ask it later. Brian Golding's chimed in with a question, and I'll just read it out for everyone. In terms of warnings, we would like to be able to make these estimates before the cyclone hits. So, I mean, there's a value, obviously, in post-event evaluation, but ideally say something before and how big it might be or how important it might be. Since you start your analysis with model data and finish with real data or data that you observe, can you say something about how well we could have predicted the damage ahead of the disaster? And maybe that relates to the validation of the model down the road. I don't know.
Yeah, so yes, this is indeed possible, and it works best for the sort of the high wind impact, low rainfall impact events. What we find is because of this mixed damage that you get through hurricanes and cyclones, the problem is that you have often landslides, storm surge, flooding, rain intrusion, as well as that wind aspect causing the damage on your infrastructure and on your buildings. And so in advance of it hitting the coast, you can obviously make these assessments based on your wind field and based on normal damage functions and so forth. But it's these four other sort of problems that you can't really handle. And so what we find is that, what I've found at least using our models, is that it's nigh on it. It's not impossible, of course, to give that assessment, but the range of it is 6-7 times. So you might be saying that it's somewhere between 300 million and 2 billion. And as then it hits, then you see, what is happening with, attenuation of the wind field, what is happening in terms of the flooding and so forth. You might then, with your rapid loss model, get it down to 500 million to 2 billion again. And then only with that damage estimation approach, where you really take the damage survey data and so forth, that's where it starts, getting down to 1.2 billion to 1.4 billion. So yeah, it's unfortunately, we're not at this point, I suppose, yet. But again, maybe with enough historical data or so forth, we might be able to bring it down enough to be able to use it. But otherwise, it's still possible, of course. But obviously, the ranges are just very big.
That's great, James. Thanks for that answer. And thank you very much for the presentation. It was really good. We'll proceed now to our final talk given by Jeff Lazo. Some of you may be familiar with Jeff's work in the area of weather-related economics, and he'll be talking today about a study they recently completed, impact-based decision support and the socioeconomic impacts of winter storms.